Hey, this is Greenfoot Ch2. Last time in Chapter 1, we got familiar with the Greenfoot framework. This time, we're actually going to write our own code from scratch. So this is very exciting. You can find this scenario, Little Crab, in Chapter 2 of the book Scenarios. And so when you open it up, it'll look like this. A lot of sand. That's the crab world. So you can see here that crab world is a subclass of world here in the class diagram. And likewise, crab is a subclass of actor. We might say crab world is a type of world and crab is a type of actor. We'll get more into that later. But let's put a crab into our world and let's see what happens when we hit act. Okay, not a whole lot. Let's try run. Yeah, still nothing at all. So we might be perplexed as to why this is. Well, if we go to open editor or double click the crab, that will work too. It'll open up the editor and we can see the source code of the crab. And as you might notice, there isn't a whole lot here. Here we've got a method called act. So this first line here is called the method signature. It tells us the name of the method, the return type, which here is void, and if there's any parameters in the parentheses. And afterwards, between the curly braces, is what we call the body of the method. That's where all the code goes that determines what the method will do when it's called. But as you can tell, there isn't any here. So it makes sense. Our mystery is solved why a crab's not doing much. So let's put in some code. It would be nice if we could make our crab I don't know, move. Maybe there's a move method. And so it turns out actually there is. And so we can call it by saying move, and then in parentheses, it requires a parameter of a number, an integer. We put a semicolon after the line. All lines of code in Java, for the most part, need semicolons after. And we hit compile. And we can see, if we go back here, we put a new crab into the environment and hit act, and the crab moves a little. Now if we hit run, it moves all the way to the right and stops at the edge. Let's move them back in the middle. Let's put a couple crabs out there. If I hit act, they all move. If I hit run, they all run to the edge. That's awesome. It works. What happens if I put in a different number, like 10? We have to hit compile. Got to put our crabs back out there. So act. He moves a little farther, and he moves a lot faster when we hit run. If I put in -10, what do you think will happen? Well, he moves the other direction to the left. We hit run, moves all the way there. Okay, so now it no longer doesn't do anything. Awesome. Another thing we can make him do, instead of move, is we could have him turn. So let's change that line of code to turn. Turn is similar of a method. You need to put in a number, an integer afterwards. So let's put in turn 3. Don't forget our semicolon. Compile. And here's our crab. If we hit act, he turns a little. We hit run, and he just keeps on turning. Looks like he's turning clockwise. If I put in a different number, say 10, guess what will happen? He turns. In fact, he turns a bit more and faster when we hit run. Change that to -10. You can probably imagine what will happen. Hit run, and he rotates the other direction, counterclockwise. Okay, so we've got move and turn. Looks like they do a fair bit. Maybe we can try doing both. So we're calling the methods, but we can also call them in sequence. So the first line here, when we call act, it will then call move with the parameter of 5, and then it'll call turn with the parameter of -10. And so let's compile that, put our crab back out. So when we hit act, it'll turn or move and then turn. So here, let's move this in a little bit so you can see better. And if we hit run, he does both. He moves and he turns, and moves in sort of a funny little circle. It's pretty cool. So, oh, and just for fun, we can put out more than one crab and have them do a coordinated dance. One thing to note here is that we wrote them in sequence, and if we're not careful, we can, if we say forgot the semicolon, we might hit compile and get an error. So you might notice that the crab class over here has this little red border. We get a little line, red block here next to the line that's offending. And down here at the bottom, it says errors found in class. Press Control K or click link on the right to go to the next error. So, and it tells us if we highlight the spot where it's underlined in red, what the error is. So here it simply says semicolon expected. We could cause another error. What if we gave move a decimal? And so again, we have an error. If we highlight it, says incompatible types, possible lossy conversion from double to int. In other words, it needed an integer, and we gave it what's called a double, a decimal number, and it wasn't happy with that and needed an integer. So this will happen a lot when you're writing code. You'll get plenty of errors. And in Greenfoot, it's very nice that they highlight it for you like this, and they'll tell you at the bottom. So let's get our code error-free again. Okay, so let's just for fun make them move pretty fast, but then maybe turn very little. Let's see what happens when we do that. So let's put our code out here, and makes a big circle, but he kind of hits the wall and does a funny little thing. And in fact, if we take away the turn, well, there seems to be no hope for him at all. He'll just run straight into the wall as he did earlier and stay there, because it seems like our crab's not allowed to move past the edge of the world. So how do we deal with this issue? It's kind of funny. Well, to do that, to maybe handle the situation a little better, we're going to have to talk about something called inheritance. We said earlier that crab world was a subclass of world, and crab was a subclass of actor. In other words, we could just say crab is a type of actor. And when that relationship is, we find that, in fact, the crab is able to do all the things that an actor can do. And we say that the crab inherited from actor. You see over here that in the code, the source code, we have this little phrase here after class crab says extends actor. So the crab actually inherits all the code from actor, and everything we write afterwards extends all the code from actor. So now we could go and break open the actor code, and we'd see all the code that is in fact available to crab, but there's no, as you can tell, there's no open editor for actor, and the reason is, well, the actor is a built-in type here for Greenfoot, and most of the time when programmers work with classes that have been written for them, or they got somewhere and they're using, they don't go to the source code unless they really want to change something about it. Instead, they'll read the documentation. So here we see open documentation. Turns out in the latest version of Greenfoot, this doesn't work so well. So instead, we'll go to help, and we'll go to the Greenfoot class documentation. This is also known as the API, which stands for Application Programming Interface, because we're programmers who are writing applications, and so we want to. This is where we get our information about these classes that we're using. So here, when you open that up, you'll see that there are several classes listed here. Here's actor. So actor is a class that we're using. Our crab is an actor. So if we click on that, we'll see information about the class actor. Instead of seeing the source code, it's put in here what's called a Java doc, which is a nice documentation about a Java class. And here we have a list of all sorts of methods that the actor has. On the left here, we have the type, the return type, and on the right we have the method, a name, and their parameters. So all together we've got signatures and descriptions of a lot of different methods that actor has. In fact, move and turn are both methods that we had and already used from the actor class. So move is over here. We notice that it says the return type is void, means it didn't have one, and it took as a parameter an integer distance. We saw earlier that if we didn't give it an integer, say we gave it a double or a decimal, it wasn't happy, caused an error. Turn is down here too. It too has void as a return type and an integer amount for the parameter, so we could tell it how much to turn. So while we're here, we're looking for something that we can find that will help us with the issue of hitting the edge of the world. So if we scroll around, we might notice that there is one that says is at edge. That sounds promising, that this might be helpful. And it says detect whether the actor has reached the edge of the world. Okay, that sounds useful. It looks like is at edge returns something called a Boolean. If you don't know what a Boolean is, it simply means true or false. It's a value of yes or no. It doesn't require any parameters, so it's more of the question type. It just asks, is it at the edge, and tells us yes or no. So since this is a method that is part of the actor class, since our crab is an actor, it inherits from an actor or is a subclass of actor, we're able to use is at edge just like we're able to use move and turn. So if we go back to Greenfoot and right click on crab, here's our list of all the methods that we've implemented or written for crab right now. But if we go to inherited from actor, we can see the list of all the methods that he can do because they are methods that actor has. So if we see Boolean is at edge and we click on it, it'll tell us right now crab's not at the edge, it's false. But if we move him over to the edge, move him there and inherit the object, or inherit from actor is at edge. Seems like we need to move him a little bit closer. Or better yet, we just run him and he runs up to the edge. Inherited from actor is at edge, and it says it returns true because the crab's all the way up at the edge. Great, this is very useful. We can now use this to maybe help us do something about us getting stuck at the edge or acting funny at the edge. This is where we're going to introduce something called the if statement, which, if you don't know, is a way to control what kinds of code we execute in different kinds of situations. So right now, as it's written in act, it always moves. But it might be the case that when we are at the edge, we would like it to do something different. So we'd always like it to move, but let's say after moving, we're going to ask if, and we put in parentheses, is at edge. So we're going to call the method is at edge, which will give us a Boolean, a true or a false, a yes or a no. And that will say if that is true, in the parentheses, and we put some brackets afterwards, curly braces after, a set of them, and everything we put inside of the curly braces will only happen, the code will only be executed if this part here is true. So let's say that when we're at the edge, we'd like him to turn. So we'll turn a little, and don't forget our semicolon, and we'll hit compile. And so if we put our crab out there and we let him run, when he gets to a wall, he turns a little. Okay, so at least he's not stuck, though he's behaving a little funny. Let's make him turn a little more. Let's have him turn, let's try 180. It looks, maybe if it's degrees, that means he'll turn around completely when he hits the wall. Let's give that a try. Put the crab out there. When we run, he turns around completely and bounces right back. Okay, that's kind of fun. A little unnatural, so maybe we'll break that down. Maybe we'll make it something more like 45, maybe a little more than 90. Let's do 100. No, let's do something like 15. That seems natural. And we'll put him back out there. Now, as you might have noticed, when he hits the wall, he turns, but he also moves. Everything that happens outside of the if statement happens every time act is called. Inside the if statement, these will only happen when it's called. There's a way to make it so that, let's say we want to make him so that he turns when he's at the edge, but he only moves when he's not at the edge. So we can put what's called an else statement. So after the if statement, if we write else, it means that if the thing here that's inside the parentheses for if is not true, so if is at edge returns false in our case, then we won't do everything that's inside of the if statement, and we'll instead do the things that are inside this block of curly braces after else. So let's say that we'll make it move 10 only if he's not at the edge. And we'll take away this line here because this happens no matter what happens about the edge. So let's compile and try this. I haven't tried this, so I don't know how this is going to go. Let's hit run. Oh, seems like we have an issue. He runs all the way to the edge and he turns, but it looks like turning is not good enough for him to get away from the edge. So let's try this. We can put more than one statement inside the if statement block. So let's say that when he's at the edge, he'll turn and he'll move, but he won't move very much. He'll move just enough to get away from the edge. So let's make him move 1. So it looks like he's barely moving. And then when he's not at the edge, he'll move 10. So let's try that. Put another crab out and see what happens. So now it looks like he's just turning on a spot because he's moving just enough to get away from the edge. But then when he's not at the edge, indeed, he moves 10. Okay. And of course, if we put anything else after the if or else statements, indeed, it will happen all the time. So maybe we like him to do a gentle curve. We'll make him turn just a single degree whenever he's not at the edge as well, or always. And this will cause him to curve around a bit. All right, let's try it. Oh, so now we have him gently curving when he's running. Okay, so this is a good start to our program. We've got our crab moving around, doing some interesting things. Just one last thing I want to point out. You might have noticed that in this text editor, we've got a lot of colored boxes. These colored boxes are not in most text editors, but in Greenfoot, they're a very helpful tool for us because they help us see what's called scope. Scope simply means, well, for our purposes right now, we'll say scope is everything between two curly braces that are matching edges. So see these two curly braces here, right after the class crab extends actor, and at the very end of the program. Together, they define the scope of the code for the class crab. Everything between these two braces belongs to the class crab as code. And so they put a nice green box around it so that we see that anything we write after here won't actually apply to the class crab. So same goes for this box right here. We have the method signature act right here. and the curly braces that go after is all the body of this method, all the code that belongs to this method, and the yellow box conveniently tells us, helps us see that it all belongs there. This is why we use indentation in Java, to help us see a little better what belongs to what. Even though the indentation is not strictly necessary in Java, but if we don't have it, it tends to be very difficult to see things and understand it. If you go in a little farther, we see another blue box right here. This blue box here belongs to this if-else pair of statements. If we take away the else, it's a little clearer that this blue box covers all the scope of this if statement. All the code that goes between these braces belongs to this if statement. If it's not true, it won't be executed. So we can kind of see this blue box is that if statement. Over here, turn 1 doesn't belong to the if statement at all. It's in this white box up here. So just a helpful tool here in Greenfoot that definitely take advantage of. The boxes will help you keep clear and readable code. Okay, so that's good enough for now. Next time we'll continue improving our crab world program, and we'll make it a little more interesting. All right, thank you. See you next time.